Learn, right? Okay, welcome to day 5. This is the last day of the unit. That means next time we see each other on Monday, we will be testing. Just kidding, we'll review first, and then we'll test. You have, did I give you those STSH review packets? Yeah. Keywords. You should have the entire pre-packet then, the coursework packet, and you probably should have the circle part of that bugger done too. Let's use this as an additional review. That way when we come next time with some deep questions on this, I think that there are a few that are a little bit confusing. So I want to be able to take questions, but I want you to have seen it first. Does that make sense? Yeah. Cool. At least it's good we're all questions. Makes sense. Let's move on. Today's actually pretty easy, I hope. We're talking about a tangent line. So what's the definition of a tangent line? From yesterday. If you don't remember, you can either look at the whiteboard, it has a picture of one, or you can look at your notes. What's a tangent line? Raise your hand if you know. Susanna. At one exact spot, right? It's just going to kiss the side of a circle. So this is a tangent line, TR. Now TR is going to, and the radius are going to form what kind of an angle? Say it. A right angle, always. Now if you have a right angle and you connect, that's a really big pen. Let's try again. If you have a right angle and you connect those two pieces, now what kind of a triangle do you have? A right triangle. So in a right triangle, we can use things like the Pythagorean theorem. On your own, will you please write what the Pythagorean theorem is in that box? We've done it before, maybe been a while. You learned it last year, you've done it this year. Pythagorean theorem says what? A squared plus b squared equals c squared. If you said that out loud, give yourself a point. Where c squared has to be the hypotenuse, the other two don't really matter. One of the ladies I watched yesterday, instead of saying square root, she said square root. So every time we're like, let's take the square root. I'm like, that's so wrong. Okay. Yeah? Some root beer? That's cute and a little bit irritating. Alright, so for these first, let's just practice Pythagorean theorem really quick to make sure you know how to do it. On part A, which one is A, which one is B, which one is C? I guess C is the only one that really matters, right? So C is what? Okay, which means the other two are A and B. Doesn't matter which. So when we set this up, 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. Then what? It's probably one of those moments that I go fast. Get rid of the 25. We can't get rid of the square root. I'm just kidding. Until we get the x squared by itself, right? Then you can take the square root of both sides. So let's get rid of the 25. 144.
Now get rid of the square root.
Now take the square root of both sides. X equals 12. We good with that? Yes, Cody. Random weird. There's a bunch more over here. You can just grab one. All right, if we feel confident about that, we can cancel these off. Actually, I want to show you something. Anytime you have a right triangle and all of the sides are whole numbers, maybe they taught this to you last year. I don't know where you learned this. It's called the Pythagorean triple. So 3, 4, 5 is the first Pythagorean triple. Then every combination or every multiple of this is also a Pythagorean triple. So 6. If we were to double it, 8, 10 would be a Pythagorean triple. If we were to triple it, it would be what? 9, 12, 15. If we were to quadruple it, it would be 12, 16, 20, and so on. So if you have two numbers, and this was 3 and this was 5, you would automatically know this one was 4 if you had those triples memorized. So it's kind of a shortcut. Now, we just found another Pythagorean triple, right? So 5, 12, 13, I have a lot of room. 5, 12, 13, also the sides of a right triangle, which means 10, 24, 26 would be one. 15, 36, 39 would be one, and so on down. Is that okay? There are infinitely many Pythagorean triples, but we're going to use our triples really quick to see if we can find the last side. So if this is 12 and this is 15, could you figure out this one? By the way, the hypotenuse is always the last one. That's kind of key. So on either of these two lists, you have a 12 and a 15. The hypotenuse is 15. You see it? So this last side would have to be what? A 9? Because 9, 12, 15 is Pythagorean triple. What about 3, 4, 5? Nice. And 8 something 10. Do we have an 8 something 10? Nice, right? PT? Yes, bunch of triples. Great. We actually will find one more pair of triples today soonish. Alright, so now we're going to transfer this onto the circle. There's several places that it's easy to make a mistake today, and I'll try to note those for you so you don't forget. I would like to start with part B. I want to find that missing side. We just have to decide first which line is going to be the tangent line, and the right angle will be right next to the tangent line. So looking at this, is the 12, the 9, or the question mark the tangent? Which one's outside the circle completely? The 12. So this is the tangent line, which means this one right here is the right angle. Because the problem says use properties of tangent lines to find each missing length, which means I know that that's a tangent line. Now if I'm setting this up, the C is always the one that kind of crosses through it, across from the 90. The A and the B don't matter. I'm assuming you don't have this Pythagorean triple memorized, but it is on the board, or if you wrote it down, oh, it's off now. So A squared plus B squared equals C squared. We're expecting the answer to be what? 15. 81 plus 144 is what? Calculate this. 225. Is that okay? I just kind of jumped. Where did I get 225? Calculator work, right? Then what? Square root confirmed. Did we get 15? Yeah. So C equals 15. What about part A? This is one that it's an easy place to make a mistake. Oh, that's supposed to be a star. Whatever. Which line would be the tangent line on part A? Is it the 6, the question, or the 4? It's the question mark. This is the tangent line, which means this angle would be the 90. It is 90. Across from the 90 is C. How long is C? This is where we have to be really careful. 4, they put a dot right here. If there's ever a dot, that just means 4 is that little length right here, which is not the entire hypotenuse. Which means on this problem, we have two unknowns. We have the tangent line that we're looking for, and then we have that little piece right there. Any ideas how you could figure out one of those two unknowns? Raise your hand if you have a thought. You don't get an extra point unless your hand's in the air. So, Casey, go for it. How? Why? Because those are wrong words. Those are. If this is a radius, this is a radius, right? So we can move that radius over. And now, do you know the size of the hypotenuse? Okay. So if you had that idea as well, go ahead and give yourself an extra point. Casey, you get 2. All right, A, B, C. Yeah, you got to volunteer. You have to be willing to be called on. And then we set up the problem just like before. So A squared plus B squared equals 10 squared. Do we know a 6 something 10?
6.
Subtract the 36. We get 64. Did we get 8 like we expected we would? Okay, we've done 2 now. What questions do you have? Ready to try one on your own? Okay, flip to the next page, try the top one on your own. I lied. Try part C. D. David, Dog, Daniel, try part D. Is it still raining outside?
It's beautiful.
It's 7.2. D. And then I want David, Dog, Daniel. And then I want David, and I want Daniel, and I said Dog, and then I probably another D word. Whoa. And then not that D word. And then somebody else asked me which problem, and then I said David, and then I said Daniel, and then I said Dog again. Delta. Dang it, will you start listening? Let's see, that's a D word. I'm just recording. I don't say bad words when I record.
That's even worse.
I know when I'm reading.
All right, so which one's the tangent line? The 7.2? So this one would be the 90. So which one would be your hypotenuse? The 9. So this would be the C, this would be the A, the B. 7.2 squared plus what? X squared or A squared equals 9 squared. Now these numbers I don't know. So then we're going to subtract the 51.84. 29 sit again. Okay, and then to cancel the squared. Square root it. So then x equals 5.4. Is it 5.4 even or is it rounded? Even? 5.4. Interesting. Cool. What about part C? I want to do part C really quick. And then you can work on your homework for, I don't know, 5 minutes or so. Pretty much. There's one more thing. So after this, you know problems 1 through 10. I need to show you how to do 11 through whatever, but it's pretty much the same, just opposite. It's still using Pythagorean theorem. There you go. Okay, what's the do-do-do? Any ideas on this one? Okay, so this would be the 90 is what you're saying. So then 12 squared plus 16 squared. When you do that, though, are you going to be getting what you want? No. Okay, so game plan. We are going to find this entire side using Pythagorean theorem, which is what we started to do, right? Okay, let's do that first. 12 squared is 144 plus 256. We had a 12, 16 something on our list. Did you write down the list? I don't know. 400 equals x squared. Take the square root, x equals 20. But that's not the x we're looking for. Now we have to, Marcus, keep talking. Why? Do we subtract 12?
Because 12 is
Our
the radius of it.
12 is the radius.
And
So this is everything besides the 12, which would give you 8. 8. How do we feel about that? Thumbs up, thumbs down, middle? Okay, cool. I'm going to pause this. Don't forget to remind me to turn it back on. All right, so this is kind of going backwards of what we were just doing. On this one, I want you to determine if AB is a tangent line. Just like you did before, you start by kind of highlighting if this is the tangent line, which angle would be the 90-degree angle? This angle A, right? Now let's fill in all of the missing pieces. We know that this is what? 17. This is what? 8. So on this particular problem, the question isn't find x or find y or find the missing side. It is to determine if that's tangent. Now if that's tangent, then this angle will be 90. So I guess technically we don't know for sure if that's a 90-degree angle. We're just kind of assuming at first. If it was a 90-degree triangle, then you'd be able to use the Pythagorean theorem, right? So if this was 90, then 8 squared plus 15 squared would equal 17 squared, right? If it was a right triangle. Do you agree?
Yeah.
So we are wondering if this works. Well, what is 8 squared plus 15 squared? Calculator work? Fast, fast. 289? 289. So you plug that into your calculator, you get 289. You plug 17 squared into your calculator, you get 289. So if it was a right triangle, then these two would be equal. Those two are equal. So what can we say about line AB? Well, so that we can say this is a 90. So yes, this is a 90 degrees. So yes, this is a tangent. I was just thinking in my head the conversation I would have if somebody asked that question. No right coordinates. Nobody asked that in first period. Do you do that? Do you have conversations in your head like, if they said this, this is what I would say? I don't do it as much as I used to. Well, that sparked a conversation. All right, so we're going to do it again. Is that tangent? Well, if that was tangent, then what would happen? By the way, could we add a number to our Pythagorean triple? We just found a new one, right? 8, 15, 17 was not on our list before. So a new one, 8, 15, 17, and any multiple underneath that would be a Pythagorean triple. And again, if you're doing something and you just use the Pythagorean triple, just put a little PT by it so that I know that that's what you did. This kind of covers showing your work. Okay. All right. So, if this is a right triangle, then 3.2 squared plus 2.4 squared equals 4 squared. So, calculator, 3.2 squared plus 2.4 squared, what is it? 16? Well, 4 squared is 16. So, are these the same? Yes? Because they're the same, we know that AB is what? Yeah, we know AB is tangent.
You have to say 80.
Yeah? With a line. Yeah, we're going to finish it off. What about part C? Will you try part C on your own? Part C. Fill out your part now. When you set this up, angle A would be the 90 if it was 90, right? So we're writing this out, 9 squared plus 12 squared equals what?
15.
How'd you get the 15? 'Cause it's not 6. Who said 15? Easy. How did you get 15? Good. This is one of those tricky ones where you have to remember to figure out the entire side. So 9 squared plus 12 squared is 15 squared. Is 9, 12, 15 one of the Pythagorean triples? Do you have it written down? 81, 225, if you plug that in. Not that it's a ton of extra work to write out the numbers and calculate it, but if you know the Pythagorean triples, then it goes faster. All right, try part D on your own, please. Maybe are you done your running for it? I don't know very many people. Anybody in here running? I know several people running next to
She was wanting to, but then didn't make anything. So she just kind of like, she's like, don't go for me. And so then you like go to like a meeting and you're doing like
So that would be the 90. Is 8.4 squared plus 13.1 squared equal to 14 squared? What is 8.4 squared plus 13.1 squared? Now I know that this can't be that, right? Why? Will you square a whole number and ever get a decimal? No. So I'm going to say no. AB is what? Not a tangent. There's a space in between there. So.